What does the Earth look like beneath the crust? This is a key question for scientists and exploration companies around the world because the lithospheric mantle beneath the crust exerts a critical control on our understanding of how the continent evolved and the location of the world's major ore deposits. Western Australia is one of the world's oldest land masses and richest resource locations, with great future potential. Imaging the lithospheric mantle is key for targeted exploration and unlocking new resources. To do this, the Geological Survey of Western Australia is undertaking one of the world's largest passive seismic projects, WA Array. WA Array is a network of small, temporary seismic stations that will be placed across the state's surface to record vibrational energy travelling through the Earth. This data will be analysed to image WA's deep subsurface. Here's how it works. Across the world, events such as earthquakes, mine and quarry blasts, ocean waves, or even road traffic produce waves of energy that travel through the Earth. These are called seismic waves. Like the way our ears receive sound waves, special devices called seismometers receive and record seismic energy. As seismic waves move through regions of the Earth with different physical properties, such as temperature and chemical composition, their speed changes, causing their direction to alter, bending the energy towards the surface. This is known as refraction. It's similar to how light waves refract and form rainbows. The WA Array seismic stations will be placed at 40-kilometre intervals across the entirety of WA, even where mining activity will never occur. This spacing is critical for allowing deep subsurface imaging without any data gaps to enable generation of a complete model of the state's internal structure. Each station has a seismometer buried just below the surface which registers seismic waves, a digitizer that stores the data, a solar-powered battery to run the instruments, and a GPS for consistent time reference across stations. Stations will record continuously for 1 year before being removed and the data recovered for processing. The variable arrival time of incident waves at different seismometers allows us to start building a picture of the different properties of the rock beneath us. So how does this help us understand the Earth? The Earth is made up of rigid tectonic plates comprised of crust and lithospheric mantle material, which together we know as the lithosphere. Like an iceberg, the lithosphere we see at the Earth's surface is a fraction of what exists. Some blocks of lithosphere have existed since almost the beginning of Earth's history. These oldest blocks, common in WA, have distinct properties of being cold compared to the material around them. The position of many world-class ore bodies correlates to where hotter material has risen through weaknesses and gaps in the old cold blocks. So understanding the topography of the lower lithosphere is critical for locating these types of resources. The sensitivity of seismic waves to the temperature and composition of the rocks makes seismic an excellent tool for deep imaging. The WA Array will help image the size, shape and position of areas with different seismic velocity. This information will help determine where the edges of old lithospheric blocks might be in WA and highlight different geological domains and structures. Combined with our existing knowledge of the WA crust, this information about the lithospheric mantle will be used to create the world's most sophisticated 3D map of the lithosphere. This will help better understand seismic hazards, inform land use decisions, and refine our geological models to determine new exploration prospects. The WA Array is a flagship project for the Geological Survey of Western Australia. The data generated will vastly expand the understanding of our state's deep subsurface structure and support ongoing exploration for critical mineral resources as we transition to net zero. To learn more and access data as it becomes available, visit our website.